To answer the question of how robots will be able to influence the design and construction process in architecture in the future, I would first like to present some existing research projects which are using robots or drones in this context. Particularly, I would like to point out two different approaches. On the one hand, the realization of architectural design with the help of robots, so to say the actual construction of a wall or a structure. On the other hand, the manufacturing with the help of robot-based processes. A well-known example of the transformation of architecture through robotics is the sequential structure project by Karamazov and Kohler Research. The construction of a wall or a timber pavilion by a robotic arm makes it possible to implement parametric designs in a completely new and precise way. For me, it represents a modern way of how architecture could change in the future and receive a completely new character. The second project I would like to present is the ICD Research Pavilion from 2016. The ICD and the Institute for Building Construction and Structural Design of the University of Stuttgart have designed this research pavilion to explore the production of glass and carbon fiber reinforced composites materials. The novel process is based on the unique properties of fiber constructions. Because these materials are lightweight and have a high tensile strength, a radically different approach to manufacturing becomes feasible, in which low actual load and long-reach machines, such as drones in combination with robotic arms, can operate. This collaborative approach enables a scalable manufacturing setup for a long-span fiber composite design. The research continues a series of successful pavilions that explore integrative computer-aided design, construction, and manufacture, in which the spatial impact and design options are analyzed. In my opinion, robotics can also achieve the effect of changing the appearance of an object or a building, not permanently but temporarily. For this reason, I would like to present the self-developed project Triangular N, which arose in cooperation with Professor Tessmann. Triangular N was designed as a food stand for a trade fair in Frankfurt, Germany. The roofing consists of single modules which are derived from origami folding. Because of the folded pockets of the modules, it is possible to connect three pieces together to create a triangular pyramid, which compound the roofing. The entire system is attached to a subconstruction. Bales are attached on the top of the triangular pyramids, through which ropes are treated. Through directed pulling on the ropes, the roofing can be folded up and down. When the food stand is closed, it has the shape of a barrel roof. When setting up the stand, the roof can be opened up. In the unfolded state, the roof forms the shape of a hyperparaboloid. Another approach for the use of robotics in architecture is the prefabrication of the construction. In order to be able to explain this procedure in more detail, I would like to present another research work by Professor Achim Minges. It represents a novel reactive architecture based on a combination of the material's natural behavior and a computer-aided process. The module is located in a glass housing in which the humidity can be regulated. In this way, the surfaces of the construction can be opened up and closed without any technical equipment or energy. I also dealt with 3D printing and its influence on architecture. Therefore, I would like to present my self-developed research project Erigami. Erigami is a simple method to create multiple programmable bending devices. By using a conventional 3D printer, it is possible to determine the folding of the inflatable objects. As a result of the simplicity of this technique, it is possible to use different materials, such as fabric, paper, or plastic. In order of testing the printed object's way of folding, a digital folding simulation was created with the help of Rhino and Kangaroo software. Simple surfaces can be uploaded to comprehend the exact mechanism of inflating and folding. By putting the pressure level up and down, it is possible to create different findings. This tool would be helpful to create and design different shapes of objects before fabricating them. The origami system allows you to create different transformations of the objects, such as you have already seen curving and rolling, simple and multiple folding, or a change of texture. The system of shape-changing materials offers you many positive aspects. Printing of complex folding edges leads you to no limitation in designing or folding objects. The multiplicity of all those projects made clear that there are limitless ways in which robotics can influence architecture, design and construction in the future. I think the possibilities of the use cases depend in particular on the designer's creativity.